I'll bring it back one day.
That hits, don't it? I told you it hits.
That's really good.
It hits. It goes down real good. I told you from day one that stuff hits.
I just switched around my shirt and I love that. I'll do it. Is there a dress? Yeah, it's straight from that. Let's do it. Maybe like last day senior year. I just don't want to. I would have. I just think you're my senior year. Like,
Still got mercy.
like I need to live a little.
Okay. Yeah. So I like it.
Boy, were you? I bet that was so depressing, wasn't it? She went home from campus.
He took off his hat. He was throwing everything that was on. He was throwing it on the ground. Oh my gosh.
You just coached.
I think I'm gonna be I love my house. I am prepared today to turn on
So it was like a stat.
Okay, so on the chart that you should have already started in your notes there, the first column is degree. The first column is degree, 0 through 4. The second column is type. It's a constant, linear, quadratic, cubic, and that last one is quartic.
I've heard that before.
There you go. Okay, so then my next column is going to be what standard form would look like. On those standard forms, I'm being a little bit of a rebel on the quadratic because we did quadratic for the last 2 units and we've talked about standard form a gazillion times and we know it's ax squared plus bx plus c. But this chart that I'm using out of this particular book, wanted to write them all in terms of a. So I did on all the rest of them, but I wrote the quadratic standard form how you know it really goes. Okay, so for a constant, it's just y equals a. There's no letter. That a will be some number, like y equals 7, y equals 12, whatever. Linear, you know, ax plus by equals c, I think is standard form of a line. Mx plus b is your more normal thing, but they threw the a's in there. So some number plus some number. There's your quadratic. Cubic, it starts at the 3rd, and quartic, it starts at the 4th.
Wait,
Okay.
how do you spell that?
Q-U-A-R-T-I-C.
Is the one
that right.
the 1 degree, is that ax plus a?
Yeah. Yeah. Okay, so degree, what you ought to, and I'll give you an example of all of them in just a second. Degree, what you ought to be able to look at that and figure out, degree of 0, there's no variable over here at all, because I told you that a is going to be a number. There's no x over here at all. So if you don't have a variable, the degree is 0. Degree of 1, that means your highest power, that x is an x to the 1st. Okay, so I kind of just gave away my secret. I didn't want to. Your degree is the highest power. We got an x to the 1st, your degree is 1. Okay? Quadratic, degree is 2, your highest power is a 2. Cubic, your degree is 3, your highest power is a 3. Quartic, degree is 4, your highest power is 4. That degree is going to determine a lot about the graphs of these polynomials that we're going to be looking at. It's going to determine which directions they go. So we're going to have to remember, degree is the highest power. We're going to talk about that a lot. Generally speaking, as far as your standard form is concerned, it goes the highest degree first, so your highest exponent first, and then just descending order or downhill from there. So if you had something, I could have a polynomial to the 5th power. I stopped at 4th, right? I could have one to the 5th power. So then standard form would be whatever to the 5th, whatever to the 4th, whatever to the 3rd. They would go downhill. Alyssa.
On the degree, on the degree 1 thingy.
Linear.
In the standard form.
AX plus A. This book likes A's for whatever reason. Just means any number. So just 4 quartic is as far as they went with cute names. That's why we don't have, there could be a degree of 5, there could be a degree of 6, and I could make up cute names for those, but it's not in a math book anywhere, so that's why they stop there at 4. But that doesn't mean that you can't have anything higher than 4th power, because y'all know that's not true. It just doesn't have, I would name it quintic, because quint is 5, but that's not real, that's just me making it up. Okay, examples. Just no letter here at all. F of x equals negative 14. Okay, linear, we can make up a million linear things. F of x equals 2x plus 6. We ought to all be able to make up an example of a quadratic. 4x squared plus 3x plus 2. Okay, you getting some good examples there. Cubic. F of x is equal to x cubed minus 2x squared plus 3x plus 4. And then quartic. Now I did that on the, when you get down there to the quartic, I did something intentionally there to see if I could get you to ask a question.
Oh my God.
Lady Jo.
Okay, so is it the power that's by 4, or how many
Good. The degree is based on the power. Okay, so let's talk about what's different. But when I got, what did I do differently when I made up an example of a quartic function? Right. This one covered all of the powers from the highest one. 3, 2, 1, nothing. 2, 1, nothing. But here I went 4, 1. I skipped 3 and 2. Okay, can I do that? Obviously I did, right? So it's based, like Lady Jo said, it's based off of the highest one. So you can skip ones. That would be like when we did the quadratic formula. If we didn't have a b, it was 0. So my 3rd power here would be a 0. My 2nd power here would be a 0. Okay? Now, I don't think today's lesson gets into types of polynomial functions, but this one would be a trinomial. You remember that from some algebra? Why is this one a trinomial? 1, 2, 3 terms. 3 is tri. Okay, 1, 2. This one would just be called a polynomial. Gets over 3. Doesn't have a fancy name. I like to name it quadrinomial, but that's not correct. That's just me making it up. This one would be a trinomial. 1, 2, 3. What would this one be? It's got 2. 1, 2. What's a 2 term? Binomial. Bicycle has 2 wheels. Binomial. What about 1 term? Monomial. Okay, very good. Y'all remember all that? Woohoo! All right, get that in your notes ready to look at so I can ask you some questions about it. Are there 2 quadratics? 4 is quartic. I can't believe you can read that. I hate it. Maybe if all y'all's parents will vote for our new high school, we can get a room where we
Nah, that's not fun.
But think about me, CJ.
I won't be here, so I definitively don't want it.
Well, that's a sorry attitude.
Yeah, if I have to suffer, I want others to suffer.
You're supposed to start on it this, like, soon.
It's supposed to be done like.
It's gonna be done next year. It's
Yeah,
supposed to be
but
done.
the last board meeting, they said they were supposed to start like any day now. The cafeteria out here, where they cleared all that out, have the fence up.
Yeah.
Maddie, where have you been?
I've only been down
Is anybody still working on the chart?
Yes,
I wish I was the same way.
I'm very proud of this.
Just go home? I go get something to eat every day. I killed 8 points this weekend.
Are you gonna go there?
It ground shrinks so bad.
Dude, that's all I saw.
It wasn't that small, Caleb.
200-pound 4 more.
You're not gonna be so small.
Gary.
It took me a solid 30 minutes to kill it.
Why?
Because I literally got in the stand here and came and I just shot it. And then right when we were loading it up in the truck, I looked over, maybe 50 yards from the truck, there's a bigger buck.
She would have shot the bigger buck.
The gun was in the truck. I didn't think someone would just come right to me and everything.
I always carry.
I gotta go.
You should. You can pack it home. You should.
Explain like the bottom one, because on the standard form there's a lot of the
Actually,
So like on my example, the next to the third
he went hunting one time and quit after that.
Yes.
He said he saw something moving in the bushes and we shot it.
I'd be so mean. Yeah.
It's not like that can line up.
It was a big dog. I could see it being a deer. It was so up to your waist. You'll see. I was like, if you ever it's not that small.
Gary's doing a small deer.
It was just tall. It wasn't wide at all.
Gary's doing a small deer.
Sorry, I get it.
Feel that.
You missed it, Dang it. You missed an 8 point.
I didn't go. I didn't get ready.
Cooper told me you'll miss one.
Yeah, Coop shot and missed, and then I shot over like
Okay, so on these four functions,
30
you
yards.
ready, Garrett? On these four functions, when I ask you to talk about whether or not it's talk about whether or not it's a polynomial function, and if it is, we're going to write it in standard form. We're going to tell its degree, its type, and its leading coefficient. So I'm going to write this down here in the bottom. We haven't talked about all of that yet. Degree, type, and leading coefficient. Yes.
May I ask what's beside that 2x4?
Yeah.
Is that a 1?
Square root.
No.
Square root of 2, x to the 4th.
Is it 12 or 1?
Yeah, that's what I'm asking.
Neither.
It's negative 12.
On the back side,
No,
Is
but
it
beside the
negative
plus.
1? Is it
Square
negative 1?
root.
Square root of 2.
plus square root of
Oh.
2, x to the 4th.
I thought it was supposed to be like
We
a
at?
No, at the end.
Well,
On
he
the
said
second
not at
equation.
the end.
the second equation.
At the end, it's minus 12, yes.
Okay, that's what I thought.
Okay, so we're going to again, we're going to again decide whether or not it's a polynomial function. If it is, we're going to write it in standard form until its degree, its type, and its leading coefficient. Okay, so number 1 up there, f of x equals negative 2x cubed plus 5x plus 8. Do you think that's a polynomial function?
Yeah.
Okay, all you've got to go off of really are the examples that we wrote down a little bit ago. Is there anything alarming that wouldn't match any of those examples there?
No.
Okay, nothing out of the ordinary, nothing scary. So yes, that is a polynomial function. Okay, so the next thing I said to do was write it in standard form. And all I've told you about standard form is your highest power comes first, and then they're descending from there. So what do you think about standard form here? It already is. Very good. I got a cubed, a first, and a nothing. I could, if I wanted to, put a 0x squared in there. That just wastes my smartboard ink and my time, so I'm not going to do that. But that's in standard form. Degree. Okay, what's the degree of that? 3. So our degree, remember that's your highest power is 3. Okay. Type.
It's a cubic, yeah.
Monomial, binomial, trinomial.
Oh.
Okay, so I've got 1, 2, 3 terms. So my type is a trinomial. All right, and the last thing I asked about was leading coefficients. Leading coefficient, I haven't described that to you yet. You know that coefficient is the number in front of the letter. It's how many of that one that you are. The leading coefficient corresponds to your degree. So since we agree our degree is 3, I'm looking at the coefficient of that term. So my leading coefficient would be negative 2. Is 5 a coefficient? Yes, just not my leading one. Is 8 a coefficient? No, because it's not in front of a letter, right? What's 8 called in terms of math if it doesn't have a letter? It's the very first row on your chart.
Monomial.
No, well, no. Constant. If it doesn't have a letter, it's constant. What are you confused on, Hot Rod?
The negative 2, like where did you write?
Go to your degree, and it's the number on that term. That's always your leading coefficient.
What do you do if you have 2? Your highest?
It's your degree is your highest. So if there had been another x cubed here, we would have combined like terms and then taken that coefficient. She's thinking fancy. I like
Good job,
it.
Miss Wright.
Michaela.
Whoa.
All right, numero dos. Number 2, g of x. Listen, g of x equals negative 0.8x cubed plus square root of 2x to the 4th minus 12.
Is that 0.8? Did you say 0.8?
Okay, well, first off, say it again.
Is that 0.8?
Yes, negative 0.8. Yes. First off, we got to decide if it's a polynomial function or not. Okay, it is. It's kind of funny looking because it's got a square root in it, but we can have square roots. We're big kids now, so we can handle that. So it is a polynomial function. Now, Grant noticed that it is not in standard form, so we need to rewrite it in standard form. So I'm going to say g of x, and how will I start this to get it in standard form?
The square root of 2x.
Okay, the term that has my highest power needs to go first. So I've got a positive square root of 2, x to the 4th. What will go next?
And negative 8x.
Okay, so my next highest power is right here, so minus 0.8x cubed. And then all I have left is the minus 12. I could put a 0x squared and a 0x if I want to, but I don't have to. So there's my standard form.
What are we trying to
Yes, let's get our degree. What's our degree? Highest power is 4. And then Garrett got my type. It's 3 terms, so trinomial.
Oh, we didn't.
Right.
Oh,
yeah.
I was thinking of like, because I was thinking it had 4 terms.
Alright, leading coefficient. So go find your term that's got the degree of 4. And the number in front of that is square root of 2. That's it. Okay, we ready for numero 3 there, h of x? H of x equals negative x squared plus 7x to the negative 1 plus 4x. So my first question is it a polynomial function?
Yes.
My answer to that is no. And it is because of that power that's a negative 1. Okay? So, let me read the way the book says it before I put it in my words. So I know my words can buzz as you sometimes. It has an exponent that is not a whole number. Okay, how is negative 1 not a whole number? Do you, and that's actually right, Lenny Joe, do you remember your exponent rules from junior high and middle school? When you have a negative exponent, what do you do? Bradley, you gotta quit knocking the table. When you have a negative exponent, goes on bottom and becomes positive. So it took something, y'all listen, took something and it's not a whole number anymore. Okay, very good, very good. So that's one of our rules on how it cannot be a polynomial function. If it's got an exponent that is not a whole number. Okay, so not a polynomial function, we don't got to do any of the rest of the stuff. That's one of those easy ones you get to jump out. Now, number 4 there, k of x. Do what, bud?
Wouldn't the last one be the same thing?
Okay, Grant's saying no on number 4. What do you think?
It's the x.
Okay, he's right. And if we try to pin it down, it does come from that. Okay, so let me see what the book words are before it's that number.
Positive number, it's not.
It does not have a variable base. So your exponent needs to be on a variable, not on a number. Okay, that's the math words for it. But I kind of like the way Grant was saying it over there. If your exponent's anything, it's not a positive number. Makes a lot, clicks in my brain a lot better.
So your exponent's got to be positive.
Correct.
So no matter what it is, you can use a quadratic. It's a
Alright, I got one problem I want us to work before we get to some cool stuff. This is a pretty easy deal here. I got f of x is equal to 2x to the 4th minus 8x squared plus 5x minus 7. The directions say to evaluate that function when x equals 3. Okay, so this is not anything new. You've done this before. The directions say evaluate f of x when x equals 3. So what are you going to do that? Very good. All you're going to do is plug the 3 in everywhere there's an x. So you're going to have 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7.
Wait, would you leave it before or would you solve that?
I need to solve that.
So you do your exponents first.
Okay, 3 to the 4th, 3 times 3 is 9 times 3 is 27 times 3 is 81. 81 times 2 is 180. No. What's 81 times 2?
162.
162. I was wanting to make it 182. Good job, Garrett. 162. 3 squared is 9 times 8 is 72. 5 times 3 is 15. 90. Y'all let me know if any of my mental math's wrong. Because it can happen. Y'all get 98?
Yeah.
For real?
Yeah.
No, I have no clue.
We'll work it out.
I'll go with that.
Y'all check it. Use your calculator, check it. My mental math can go askew from time to time.
So 98 your answer.
You got it too?
Wait, how did you ask?
I did 15 minus 7.
Because
Okay.
80, times 3 is 24, so 40.
Yeah, that's what I got.
Yeah, that's what I got.
Okay, so next thing we got to talk about is end behavior. End behavior means what's happening where you draw the arrows on your graph. So if you think about the things that you already know how to graph pretty good. If you were to graph a line like that, end behavior, that thing's going to keep going to the right and up forever. This thing's going to keep going to the left and down forever. If we think about some parabolas, ones like this, they would keep going up forever. Here they would keep going down forever. So there's going to be some rules. You don't need to write that down. There's going to be some rules that we're going to make here on this little chart. We're just making some charts today, aren't we, friends? Alright, so this first upper left, we're going to describe the end behavior if our degree is an odd number and if our leading coefficient is a positive number. Okay, so upper left quadrant on your chart is going to be a graph if your degree is an odd number. That means your highest power is an odd, 1, 3, 5, 7, if your degree is an odd number, and if your leading coefficient is a positive number. Okay, an example of a graph would look something like that. I'm going to get you all the info, and then I'll try to give you some words to it. It needs to be in quadrant 1 like that.
Oh, okay.
These things that I'm writing right now that looks like hieroglyphics, that needs to be on those sides of the graph. So this one needs to be over here by this arrow, and what I'm writing here needs to be over here by this arrow.
Are those circles?
Infinities.
Oh. Wait, is the degree? What's the one under?
Let me finish, and I'll because I'm gonna have to explain a lot.
Come on, guys. Handwriting's not that bad.
Okay. So what we've got over here on the right side, talking about this arrow on the right side.
Attention students, if you are a senior football player or a senior tennis player, we have the senior night forms in the high school office. Please come by and get those and take them home to fill out. Thank you.
What's happening over here on the right side with this right arrow? These things, that arrow in math, that reads approaches. So I would read this, f of x approaches positive infinity as x approaches positive infinity. So over here on this right arrow, everything's approaching positive infinity. As f of x approaches positive infinity, as x approaches positive infinity. And I'll explain that to you. Just get it in your notes. We ready for me to wait a second, or are you ready already?
Wait.
Okay, I got you.
Question, is the degree is an odd number and the leading coefficient is a positive number? Is that supposed to be in?
Yes.
Wait, and the next side is just like the opposite.
Uh-huh.
So that says like.
Those y'all that are ahead, the other side is just negative infinities.
It just like a sideways 8. Does this say plus?
I got this.
Positive infinity.
I just, yeah.
So over here, f of x approaches negative infinity as x approaches negative infinity. F of x approaches negative infinity as x approaches negative infinity. So here's what you need to know about this infinity stuff. The x is your left and right. You got that. F of x is your up and down, right? Because f of x is the same as y, which is your up and down. So f of x is approaching positive infinity. That means you keep going up. The higher up this graph gets, it's also going to get wider. So they're both up and right. That's positive. It's going to keep growing up and right. Over here, lower, negative. Also goes more to the left, negative. Okay? Make pretty good sense on that. Now, here's the way my bonehead brain works on these. An odd power, that means my graph is going to get to do a disco dance because the ends are going to go in opposite directions. So think of a line. That's a power of 1. The ends go in opposite directions, right? Opposite directions, that's your John Travolta disco dance there. You get to disco. Opposite, odd, disco. Leading coefficient's a positive number. That means as you read your graph left to right, it goes uphill first. We've talked a lot about me riding my bike on the graphs. When it's a positive number, I got to climb the hill first. So this is going generally uphill. Okay? So odd, disco, leading coefficient positive, it's going uphill first. Okay? Fill in the rest of those blocks. Top right, we're going to stick with our degree of odd. So you know it's a disco. But we're going to talk about a leading coefficient that's negative. So you ought to know now how you could draw an example. Degree odd, it's going to be a disco. Ends are going to go in opposite directions. But a negative leading coefficient means it would have to go downhill first. So it could look something like that. Okay, so let's do this side first this time. This side that I'm writing on, f of x to y is going up over here, right? So it's approaching positive infinity. And as it does that, x is going to the left. So x would be approaching negative infinity. Over here, my y is going down. So it's approaching negative infinity. And as it does that, my x is going to the right. So it's approaching positive infinity. You just turn it sideways. Try to make those things stand out.
So x equals positive infinity. On the second one. So there's no negative.
Right here? Yeah, that was positive infinity. Right here, it's negative infinity. Because that's where it goes to the left. X is going to the left, it's negative infinity. Okay, the bottom two on our graph is going to be our even degrees. So I'll go ahead and write that in both of them. And then to stick with what we've done on the top, we'll put our leading coefficient positive over here and our leading coefficient negative over here. Alright, so if odd degrees made the ends go in opposite directions, what do you think even degrees will do? What do the ends do on a parabola? They go in the same direction. Very good. So if my degree is even and my leading coefficient is positive, they're going to both point up. And you know that because a parabola's got an even degree. So if it's a positive leading coefficient, if your A is positive, it makes a U. Okay, so something along those lines there. Over here on the left side, my f of x is going up. So it's approaching positive infinity. But my x is going to the left. So it's approaching negative infinity. Over here on the right, my f of x is going up. So it's approaching positive infinity. But my x is going to the right. So it's approaching positive infinity. that square now, you know what that graph's got to look like. It's an even degree, so they got to go in the same direction, but the leading coefficient's negative. So think about a negative a on your parabola.
So
They point down. So we're going to have ends going both down, so we can have something that looks like that. Okay, now to fill in my infinities here, both of my f of x's are going down, so on both sides your f of x's are going to approach negative infinity. Over here on the left side, my x is going to the left, so it's going to approach negative infinity. But on the right side, my x is going to the right, so it's going to approach positive infinity. Right. So put some more of my boneheaded words on it. We get to disco dance if our degree is odd. If my degree is even. Touchdown. 3-pointer. Ends go in the same direction. Okay?
Field goal.
Field goal. Alright, when you get that note finished up, I'm going to give you a polynomial and see if we can use that stuff to describe it. I bet you we can. You bet your boots.
I'm almost done. I'm just a little behind. Because I'm kind of
20 lashes really wet now for you if you're behind.
We didn't.
Look, I'm almost done.
Dang.
That's so bad.
Easy.
I just know that I'm hungry, so you probably have to make the office for it. The first thing I have to say
Speed the days when you say like $5
that would get to me.
Pretty this hard. It's like being that going overboard.
Stop.
Really think about it.
Hurry up, Tori. Just look online. I look.
Oh my gosh, Tori, come on.
Alright, so studying there on that chart that you've made, I've got f of x is equal to negative 0.5 x to the fourth plus 2.5 x squared plus u plus x minus 1. All the directions say to do here, negative 0.5 x to the fourth, yes. All the directions say to do here is to describe the end behavior. That's it. Describe the end behavior. So in order to describe the end behavior, I got to know two things. I got to know what my degree is, and I got to know what my leading coefficient is.
Your leading coefficient is 0.5.
No.
Your degree is 4.
Degree is 4. I'll go with that. What's my leading coefficient? Negative 0.5. Forgot your negative on there. It was all G'd up. Negative 0.5. Okay? Now stop me right now if you don't know where Garrett and Grant got those numbers from, because we got to know. All right, Michaela, degree. Highest power. Chloe, highest power.
I'm so confused.
I was like, I really don't understand, but I didn't raise my hand.
No, I understand.
I'm just teasing. Highest power. So you got the degree, Chloe, degree, highest power. Leading coefficient, you go to that term, and it's the number in front of it.
Oh,
That's what
it's the fourth one.
Okay, so we've got a degree of 4. Is 4 an even or an odd number?
even.
It's an even. So I know this is a touchdown. Is it a touchdown, or are they both going down?
They're both going down.
Both going down because of that negative. Okay? Now, if this were a quadratic, we know it would just look like that. But because this is a fourth power, there could be more bumps involved in it. Like the example that I drew could have a McDonald's arch or something. We'll get into graphs in just a second. But to describe the leading behavior, the answer you would write, look in that quadrant where you've got an even and a negative. You would say as f of, not 2f, stupid, as f of x, my y, approaches negative infinity. X also approaches negative infinity. Right? Isn't that what's on the left side? You following your chart? Over on the right side, f of x is again approaching negative infinity. But over here, my x approaches a positive infinity. We just copied that right off our chart. So if you're able to identify that degree and leading coefficient and get in the right place on your chart, you can't mess that up, right?
Right. I guarantee you I can mess that up.
No, Michaela.
I mean,
How can
unless
you
you
get the
wrote
negative
the chart
before
wrong.
the infinity or something?
Oh, y'all just gotta be careful. Careful.
So what's, I just don't, this
So all that stuff I wrote in blue was the answer.
Is that a negative?
Right here, negative? Yes.
Kayla, you're dying.
Wait, so we're describing it
In behavior.
in behavior. That's
Alright, after you get that one finished, we just got one more problem to look at today.
And
Not
Kayla,
right now.
Paul has a question.
Maybe we did earlier.
Weird, we haven't man. You got a deep voice, that guy.
Alright, we ready, Freddie?
Try not to get sick. We're gonna give you a Tums.
Exactly. Some crackers maybe?
You can't even taste it.
Oh, we're dropping now?
We're gonna grab
We're
one.
getting fancy?
That would be the
Don't
nose.
worry, these aren't straight lines.
Little, you can break your leg. You want some ice? No, I don't want no ice. It's broke.
Okay, so our directions this time are going to say to graph the polynomial function. Before we do graph it, I want to get an idea of what I should expect it to look like. So my degree is 3. Everybody follow that? My degree is 3, which is an odd number, which means a disco. The leading coefficient of that is a -1, which means it's got to go
So it's gonna go down and then
downhill
up.
first. So if it were just a line, it would look like that. But a 3 is not a line. It's got some curves in it, so it's going to be something snaky looking. Okay? Alright, so what will we do if we got an idea, but we can't just say, well, there's the graph. You know, we've got to have some specific points. So what will we do to graph that with some specific points? That's a good idea. I heard plug in something. Okay, so that's exactly what you're going to do. That's why we had a problem earlier where we plugged the 3 in. Same thing. We're going to pick our own x's to plug in. Now, here's my guidance to you. Whatever you pick to plug in, you have to graph. So if you think it's funny to plug in x is 100, that means you've got to graph that. So I'm going to try to keep my numbers small and manageable when I can. I always want to see negatives and positives. So I'm just going to go -2, -1, 0, 1, 2. Those are the numbers that most of the time you're going to see me plug in. Okay, so what I want you to do right now, you're going to have -2 cubed plus -2 squared plus 3 times -2 minus 3. You're going to get an answer for that, and that'll go right there next to the -2. Then you're going to do the same for -1.
It's a lot of work.
And you hadn't even started yet. It's a -3 on the end. And you're going to do the same for your 0.
Wouldn't that just be 0? No.
You're going to do the same for your 1. And I got one more. I'm going to do the 2. Alright, so those are the 5 problems you're working on right now. Eric, you got 5 problems to do.
I don't call this.
They got -2 yet?
I got
3 is good.
Oh.
Check it. If you didn't get 3, check it. 3 is correct. What about -1?
Oh,
Yes, I got -1.
What'd you get for -1? -4. What'd you get for 0?
-3.
What'd you get for 1? Anybody got that far yet? No, 1 is not 2.
Also got 0.
1 is 0. Good. And anybody got the last one yet? Why are you square rooting anything?
I got -1.
-1 is correct. Okay, so these are the 5 points I'm going to plot. I'm going to go left 2 up 3, and then left 1 down 4. Y'all know how to plot those, so I'm going to go ahead and get rolling on them. Left 2 up 3, left 1 down 4. Gotta scroll this down a little bit. 1, 2, 3, 4. 0, 1, 2, 3, 1, 0, and 2, -1. So now I'll just connect those. Let's see if I can get them all in the. Where's my -1? I gotta get, there it is. Man, that would be some kind of drop off to ride your bike on, wouldn't it? Now, if they're at the top, I didn't have much room to extend it, but you do know that this does keep going forever. That's why the infinities are there. So, should look something in that area. This is, remember what we guessed? A downhill snake. So, did we get something that would confirm a downhill snake? Yeah. It's a lot sharper, but yes, it did go make a downhill snake on that. Hi. Any questions on today's stuff?
Really, it's pretty easy.
It's not bad at all. The polynomials are not bad because you're already fabulous at quadratics.
My boss.
All right, so we'll pick it up on doing some operations.